Now we'll take a look at a few examples using the triangle inequality theorems. So for exercises 6 through 8, I want to list the angles of the triangle from smallest to largest. Okay, you always have to make sure that you follow the directions. Sometimes it's largest to smallest, sometimes it's smallest to largest. But what you want to take a look at, if you're going from smallest to largest, is what the shortest side in the triangle is. So on number 6, 6 is definitely the shortest side in the triangle. The angle opposite that is angle C. So angle C is the smallest angle. I could write inequalities. It doesn't say to write inequalities. It just says list the angles from smallest to largest. So angle C would be the smallest angle. The middle angle would be opposite the middle side. The middle side here is 8. So the angle opposite that is angle A. Angle A is the middle angle. And then angle B is opposite the longest side. So angle B is the largest angle. Okay, take a minute, pause the video here, see if you can work through number 7. On number 7, if you said that angle D is the smallest angle, that would be correct. It's opposite the shortest side. Angle E would be the middle angle. It's opposite the middle side. And then angle F would be the largest angle. Okay, it's also true, just to double check, these are definitely sides of a triangle, because if you take the sum of any two sides, like 18 plus 7, okay, that's 25. That's definitely greater than 15. 18 plus 15, 33. That's definitely greater than 7. If you figured it out, to check if these three sides make a triangle, all you really need to do is add the two shortest sides. 7 plus 15, 22. That's greater than 18. Because it has to be true that the two longer sides, 18 and 15, if you take the sum there, they have to be greater than the third side, which is the shortest side here, 7. And it has to be true that the longest side and the shortest side, 18 plus 7, if 18 is the longest side, the sum there definitely has to be greater than the middle side there. All right. And then on, which leads to numbers 9 through 12. Okay. Is it possible to create or construct a triangle with the given side lengths? If so, explain, or sorry, if not, explain. So if you take the sum of any two sides, 3 plus 17, that's the shortest and longest side, 20, that's definitely greater than 12. The two longer sides, 12 plus 17, 29, that's definitely greater than 3. Okay. If that takes too long, which it doesn't take that long, all you really have to do is add the two shortest sides, 3 plus 12. Is that greater than, I'm going to put a question mark here, 17, so 3 plus 12, 15, that's not greater than 17, so it's not possible to have a triangle with those given side lengths, specifically by the triangle inequality theorem. And maybe take a minute, work through number 10, possibly 11, to see if those three sides make a triangle. So on number 10, if you only wanted to check one sum, you would only have to add the 5 and 16. 5 plus 16 is 21. Is that greater than 21? In fact, it's not. It's equal to 21. If you think about what's going on there, you have a side length that's 5 units in length, a side length that's 16 units in length, and one that's 21. You try to create a triangle, whatever you have these made out of, just like sticks or whatnot. What would happen is these two shorter sides, 5 and 16, would just lay on top of the side length that's 21, and they would not make a triangle. They just make like a segment or a line. All right, and then on number 11, if you added the two shorter sides, 5 and 7, 5 plus 7, 12, that's definitely greater than 8. So yes, these three sides make a triangle. If you're wondering, well, don't the sum of any two sides have to add up to be greater than the third side? Yes. But if you add 8 and 5, that's 13. That's definitely greater than 7. If you add 8 and 7, 15, that's definitely greater than 5. So yes. And then one last example with triangle inequalities. Think about this before we go over the answer. If you have two sides of a triangle, or 5 and 13, try to figure out all the possible lengths of the third side of the triangle. If you figured out the possible lengths of the third side of the triangle, the smallest that's the third side length could be, if I let that be x, would be, did you figure it out? Has to be more than 8. Anything more than 8, such as 8.1. Because if you add like 8.1 to 5, that's 13.1. That's greater than 13. Can't be exactly 8, So x, the third side length, has to be greater than 8, not greater than or equal 8, and then less than, did you figure it out? 18. So anywhere between 8 and 18, not including those two side lengths, because if you had something like 17.9, okay, that's less than 18. If you add these two side lengths up, 5 plus 13, 18, that's greater than 17.9. Okay, it can't be equal to 18 because if you add 5 and 13, then those two sides would equal this side length. For any problem, let's just say I was given two side lengths are, I don't know, 9 and 12. Then if x is a third side length, the third side length has to be greater than 3 and then less than 21. So if you're given any two side lengths, if you figured out how to come up with, this is a compound inequality, x, the third side length, let's just say you have two side lengths, a and b, has to be greater than the difference, a minus b. If a is greater than b, you can take the absolute value and make sure that that's a positive number, and then less than the sum, a plus b. That's how I got the 21, added up these two side lengths. That's how I got the 3, subtracted 13 minus 5. Sorry, 12 minus 9 is the example that I used there. But if you did 9 minus 12, that's negative 3. You would just take the absolute value. But you know that 12 is greater than 9, so you can just take the larger number minus the smallest number. And then the same with the 5 and the 13. This is the sum, 5 plus 13. This is a difference, 13 minus 5.